Hello everyone, my name is Camilo Escobar Velázquez. I work with the Software Design Lab from Universidad de los Andes in Colombia, and today I'm going to present our paper called An Empirical Study of Internationalization Collateral Changes and Issues in Graphic User Interfaces of Android Apps. Why internationalization is important? Since mobile markets provide access to apps around the world, and being Android one of the top operating systems for mobile devices, enabling the usage of an app in different countries and in different languages might help track attention and more users to different apps. First, we define internationalization as the set of efforts required to enable the usage of an application in different languages. As it can be seen in the bottom left image, this is not related only to the translation of text, but also to the validation of design metaphor in the final languages. As we are going to see later, there are different types of issues and changes that can be seen in Android apps when internationalized. So Android apps use a set of files called string XML in order to enable internationalization. So for each language, there is a specific folder named after its acronym storing the aforementioned file. So in Portuguese, we have values-pt folder as an example. Nevertheless, the default internationalization protocol defined to generate a new version of the strings XML requires the manual translation of strings. And as you might notice, this is an error-prone and cumbersome process. What has been proposed to solve this? First, we have 3 papers where they propose the automation of the detection of need to translate strings for web apps, for web and Java apps. And we also have a 4th paper to translate the strings, but in offline mode. So the strings are translated, but are not incorporated into the app. And we also have the papers on identification in internationalization presentation failures in web apps by Abdul Majid Alamir and Sonal Mahajan. So in order to make our research, we create a tool called i18n that allows us to detect the hard-coded strings, also to detect not internationalized string, to automate the translation of strings from string.xml file, to systematically explore the translated and base apps, and also to automatically detect the changes due to internationalization process. First, we have to see the base for our study, that is the layout graph that represents the relations between components in an interface. So in this case, we have the button A and all the relation with all the components seen in this image. This is the architecture of i18n. Since this is not a tool demo paper, I'm going to pass really quick on this. We have an original APK that we decode using APK tool, where we find the hard-coded strings and not internationalized strings. Then we send those strings to the translator, where we translate it and generate the strings.xml files. And then we create or build an internationalized APK file. Then we explore it, the base version, the English version, and also we explore the 7 languages versions, replicating or replaying the first exploration phase. Once we have done this, we have the layout graphs for each base and translated version, and we compare them in order to identify the changes. So this is an example of an internationalization collateral change, where the button in the center has grown and its dimensions has changed due to internationalization. So in order to check our approach, we made an empirical study where we try to answer these 3 research questions. We are going to go through each one later. So as the context of this empirical study, we extract 211 apps from 3 previous papers and some data sets that we generated for previous studies. We filter these apps by its availability in Google Play, if they run in an Android API greater than 27. Also, if in the systematic exploration returns more than one activity, or in case it has only one activity, it has more than one state. At the end, we select 31 Android apps. Each app of these 31 was translated, was gone through Detroit. So we had at the end 270 translated versions of each app. It worth noticing that we are talking again about 31 APKs, but each APK has 8 languages incorporated. So we can talk about 217 translated versions and 31 base versions. So after running iterate over those apps, we found 402 internationalization collateral changes cases that was evaluated by the authors in group of 3. After this tagging, we found 273 cases where the authors agree in the tag and 129 conflicts solved by 3 authors. So regarding the research questions, the first one was what type of internationalization collateral changes and bugs are exhibited in GUIs, in graphic user interfaces of Android apps. So we have found 3 main categories. The first one are the collateral changes, that are the changes that we found in the layout graph. The second one are the bad coding practices, where we are talking about the files. First one are the hard-coded strings, that are the strings that are inside the code, or the smiley intermediate representation. The second one is the non-existent translated string resource file. Not all apps have strings.xml file for all the languages. And the third one is the no string resource file, that we found that one application do not have a string.xml file, so all its strings are hard-coded. And the third category is the collateral bugs, where we are going to talk about that in the next research question, that is the what internationalization collateral changes induce internationalization collateral bugs on graphic user interfaces on Android apps. The first one is the lack of mirrored layout for right-to-left languages. We saw that 15 apps do not have the change of meaning of the mirrored layout, and this generate 38 collateral failures. Second, we found the overflow component due to internationalization text expansion, where due to the length of the new language, the layout changed and broke. We found 2 apps with this, and the 2 apps had 29 collateral failures cases. The fourth one are the overlap components, where, as we can see in the right image, the text length goes over the component and overflows it, overlaps it. And the last one is the loss component, where, as we can see, we are not looking anymore at the bottom of the left image. And what are the GUI components and languages more prone to international collateral changes and bugs? We found that a lot of Arabic collateral changes, but only 39 of those were failures, since those 39 broke the layout. The next one was Russian, due to the length of the text. So in terms of the components, we have the text view and the linear layout being the most impacted components. We thank you for being here and to listen us. Please go to our online appendix.